Assalamu alaikum wa rahmatullah. Ahlan bil jamee. Hi everyone. Today inshallah we will gonna solve homework 2 for the course MSE 201 Introduction to Material. Bismillah, let's start. The first question said, determine the radius of the palladium atom, give that BD has an FCC structure. Okay, we know that it has FCC structure. And also he said that a density of 12 gram per centimeter cube and an atomic weight 106.4 gram per mole. And he gives us also the Avogadro number. So what he need determine the radius of the palladium. So we need to find the radius. And also what he gives us, let's analyze the question. He gives us that we have FCC structure, which means that we have 4 atoms per unit cell. And also he gives us the density, which is 12 gram per centimeter cube. Okay, and also he gives us the Avogadro number. What we can do while we are needing to find the radius, we can apply the density law, which says that if we have the density law, the density is equal to the number of the atoms within the crystal multiplying by the atomic weight over the volume of the unit cell multiplying by the Avogadro number. Okay, we have the atomic weight, we have the number, and we have the Avogadro number, and also we have the density. From the volume, we can find a relationship. The volume, what's the volume for the unit cell? It's basically a to the power 3, a cube. Okay, so by finding a relationship between a and r, we can substitute r based on a in this equation and find what is r. Okay, let's do it. Imagine that this is the FCC structure. What we can do, we can find the relation between a and r. We know that this side is a and also this side is a. The FCC structure we have in the face, we have here 1/4 atom, and also here 1/4 atom, and also here we have 1 atom. So we can know that this is r, this is 2r, and this is r. By adding all of these to find the length of this diagonal, we can say that r plus 2r is equal to 4r, and by finding the relation between a and r by Pythagoras theorem, we can square the 4r is equal to, which is the diagonal equal side 1 squared plus side 2 squared. Okay, then let's solve for a. We can say that 2a squared is equal to 16r squared. Simplify. We are having a is equal to taking the square root of 8r, which is basically a is equal to 2 square root of 2r. Okay, so now we find the relationship between a and r. We can just substitute it in the origin equation. Okay, let's substitute. We can say that the density is equal to the number multiplying by atomic weight over the VC, which is a cube, and the a we find it by that. We can say that it is 2 square root of 2 r cube multiplying by Avogadro number. Okay, let's take r on one side. We will gonna have r is equal to the third squared root of n multiplying by a over the density multiplying by Avogadro number multiplying by 2 square root of 2 to the power 3. Okay, just to plug in the numbers, you will gonna find that the R is equal to 1.38 multiplying by 10 to the power minus 8. طبعا اليونت هنا لو تلاحظون ان الدنسيتي عندنا with centimeter, so the radius that we will get is centimeter. So if we need to convert the unit from centimeter to meter, we can basically use this logic, which is put the centimeter in the denominator, and we know that in each centimeter in meter we have 10 to the power minus 2. So we will gonna have that R is equal to 1.38 multiplying by 10 to the power minus 10 meter. And also you can convert to nanometer if he asks. Okay, let's move on to the next question. He said that titanium has an HCP crystal structure and a density of 4.51 gram per centimeter cube. And the atomic weight, he gives us the atomic weight. And also he gives us the Avogadro number. So what he needs in the first part, he needs what is the volume of its unit cell in a cubic meter. Okay, what we can do basically same as what we did in the first question. We can find the volume by using the density law, which is density is equal to the number of atoms in the crystal structure multiplying by the atomic weight over the Avogadro number multiplying by, that's what we need, by the volume of the unit cell. Okay, طيب. He gives us that it's HCB, which means that we have 6 atoms. This is the N. And also he gives us the density is 4.51, and also he gives us the atomic weight. So let's just arrange our equation and put the VC in one side. Then we will gonna have that N multiplying by A over the density multiplying by Avogadro number. Okay, we will gonna have 6, the number of atoms, multiplying by the atomic weight, which is, he gives us, it is 4.51. طبعا اليونت هنا بالجرام per centimeter cube, so we have to convert it at least because he needs it in a meter. Okay, and also we know that the density is equal to 4.51. okay, عذرا هنا الأتوميك ويت عندنا 74.87. okay, multiplying by Avogadro number, which is 6.022 في 10 to the power 23. Okay, then the final answer, it will gonna be in centimeter cube, as I mentioned that the density that we have in centimeter, so the volume also we will gonna have it in centimeter. So if we compute it in the calculator, we are gonna have that the VC is equal to 1.0575 multiplying by 10 to the power minus 22. طبعا اليونت centimeter cube per unit cell. Okay, if we need to convert it to meter, what we will gonna do, we will gonna put this ratio. We put the centimeter, what we want to get rid from it, and the meter above. Okay, how many centimeter in meter? We have 10 to the power minus 2, and also here we have to the power 3, so all of it to the power 3. If we do it in calculator, we will gonna find that the VC is equal to 1.057 multiplying by 10 to the power minus 28 meter cube per unit cell. Okay, let's move on to the other question. The other question, he said that if the C over A ratio is 1.58, compute the values of C and A. طبعا what is C and A in the hexagonal? C is basically this side is C, which is represent the height of the hexagonal, and the A it is this side. Okay, and he gives us the ratio between them, and he wants from us to find the value for each of them. What we will gonna do? We can find their values by using the volume, which is we are already finding the value of the volume. Okay, how we will gonna start? We will gonna find an equation that represent the volume of the hexagonal. So basically, it is not just like a sphere that we have a specific equation for the volume, or we are not memorize it. Okay, so basically we're gonna try to find a law for the volume. طيب. Basically, if we need to find the volume, it is basically the volume is equal to the base multiplying by the height. Okay, and the height it's as I mentioned before, it is C. What is the base? The base is hexagonal shape. Do we have a specific formula for hexagonal area? No. So what we will gonna do? We will gonna divide it into six triangles. Then we will gonna find the area of just one triangle and then multiply it by 6. Okay. How can we find the dimension of the triangle? We know that this side is A. But do we know the height of this triangle? No. How can we do? We can do it by using this relationship. We know that this angle is 60 and this angle is 30. So we will gonna use the similarity of the triangles and find the relationship between them. في المثلث المشهور 60 30 we know that this side is equal to 1 and the hypothesis is 2 and this one is square root of 3. Okay, but in our case what do we have? We have in the base we have a over 2 عندنا نص هذا اللي يمثل لنا a over 2. Okay, and do we know this? أصلا we don't need this. Do we know this? We need to find it. We will gonna name it as x. Okay, let's do a ratio between them. By this triangle we can say that the square root of 3 over 1 is equal to, okay, let's do the same thing with it. We will gonna do x over a over 2. okay, نسبة وتناسب ونقدر نطلع الفاليو حقة الx بالنسبة لل a. okay, x is basically is equal to a square root of 3 over 2. طيب تمام. إيش الاريا راح تطلع لنا؟ راح ناخذ الهايت which is c multiplying by the base. طيب البيس إيش عبارة عنه؟ إحنا قلنا إن عندنا أول شيء عندنا 6 مثلثات. طيب المثلث الواحد كم القانون حقه؟ عندنا half multiplying by the base of the triangle which is this is all the base. Okay, let's do it in another color. This is the base which is represent a multiplying by the height which is representing the x. We just find it. Okay, multiplying by a square root of 3 over 2. طيب we can simplify. We will gonna say that here 6 multiplying by half a multiplying by a square root of 3 over 2. we can say that the area is equal to C multiplying by, we can cancel 3 square root of 3a square over 2. Okay. طيب. Let's gonna plug in it into our question or our equation. We know that the volume, the VC is equal to that we just derived it, this one. Okay. And we know the value of the VC, which is we just found it in the previous part. Okay. Now, if you think about this equation, we have two variables with one equation, so we can't find the value of each of them. So what we need to find another equation to determine whether A or C, okay, and replace them. Okay, we can do another equation by using this relation. We can do that. The C over A is equal to 1.58. Okay. طيب. We can see that the C is equal to A multiplying by 1.58. And just plug in the C value into this equation. So VC is equal to A, or let's do it 1.58, A multiplying by 3 square root of 3, A squared over 2. We know the value for VC, which is we just found it, this value. Okay. So we can move all of these, which is this number to the other side. So if we can have 2 here, 3 square root of 3 multiplying by 1.58, which is equal to A to the power 3. And just take the third cube for both sides, and you will gonna find the value for A, which is will gonna be that A is equal to 0.29, 2.95 10 to the power minus 10. طبعا الوحدة بالمتر لأن الفوليوم أساسا بالمتر. Okay. You can plug in the value of A on here and just found the value for C, and you will get it that C is equal to 4.66 multiplying by 10 to the power minus 10 meter, and you can also convert it to the nanometer if he asks you to do that. Okay, let's go to the third part of this question, which is he need to compute the planar density of the plane 0001. Where's the plane 001? 001, which means that it is parallel to the A1 and also to the A2, and also it is on the z-axis, 1 unit above the z-axis, which is basically this area. Okay, the top surface of the hexagon. Okay, the planar density, as we know, it's low. It is the number of atoms centered on the plane divided by the area of the plane. Okay, the area of the plane just we calculated which is this law on the previous question. And also the number of the atoms, we can calculate it. Okay. There is so many questions in the group that they ask about how we can count the atoms in the plane. Okay. Basically, you can, by knowing this angle, which is 120, you can know the amount of the angle that we have in this corner. Okay. By how? By doing this relationship. As we know, we have the angle 120. The whole circle is 360. And also we know in the 360 we have one full atom. So how many atom that we how many atom that we have in the angle 120? You will gonna find that we have the third of the whole atom in this part. So how many atom we have? We have هنا third وهنا third وهنا third. So basically you will gonna multiply the third by the number of the atoms on the plane. So we have 1, 2, 3, 4, 5, 6 multiplying by third, which is 2. And also we have one atom in the center of the plane, which is one full atom. So one atom in the corners and one atom in the center. So totally we have two atoms within this plane. Okay. No, basically no. We have third multiplying by 6 atoms, which is 2 atoms, and also we have one atom in the center, which is 1. Then you will gonna have 3 atoms. Okay. So what you will gonna do? We have 3 atoms over the area, which is we just find it. 3 square root of 3 a square over 4. Okay. And a also we have found it. You just plug in the number and you will gonna find that the planar density is equal to 1.326 multiplying by 10 to the power 19 meter. طبعا اليونت هنا meter per minus 2. Okay. Per unit meter. Okay. If you want to convert the units to the nanometer, what you will gonna do? We know that 1.326 multiplying by 10 to the power 19 over meter square, which is just, this is a negative, so we put it down. Multiplying by, we need to get rid from the meter, so we put it in the above. And we want the unit nanometer. So how many nanometer in meter? We have 10 to the power minus 9. And also we have here to the power 2. So we will gonna multiply it by to the power 2 also. And basically the answer you will gonna find it in nanometer by this solution. Okay. Let's move on to the question number 3. He said that the unit cell volume of a given metal is 4.7, etc. Okay, within the theoretical density, he gives us the theoretical density. If that atomic weight, he gives us the atomic weight and the atomic radius. Okay. What's he need? He need to find the metal crystal structure. Okay, the key bonds here, he gives us the density and he gives us the radius and also he gives us the atomic mass. So what we can do, we can find the number of atoms, and based on the number of the atoms that we get, we can determine whether it's FCC, BCC, HCP, simple, cubic, etc. Okay, if we get like basically like here, if we get 4 atoms, we will gonna have FCC. If we have 2 atoms, we will get BCC, and if we get 6 atoms, we will gonna have HCP structure. Okay, let's start by using this equation, which is the theoretical density, we can put the number of atoms in one side and we can solve based on it. Okay. Do we have the volume? No, we don't have the volume, but we have the radius, which is a nanometer. So basically we have to find the volume. Okay. Which is the theoretical density, which is what he gives us. He gives us, as you can see, where, yes, in gram per centimeter cube. So we have to convert it into gram per meter cube. So how can we convert it? 8.89 gram per centimeter cube. We can multiply it by centimeter here, 10 to the power minus 2 meter square. You will gonna find that it is equal to 8.89 multiplied by 10 to the power 6 gram per meter cube. Okay. Okay, as you can see, also he gives us the volume, which is directly we can use. So after converted the density, we have 8.89 multiplying by 10 to the power 6, multiplying by the volume, which is 4.745, multiplying by 10 to the power minus 29, multiplying by the number of Avogadro over the atomic weight, which is 63.5. Okay. If you plug in this number in the calculator, you will gonna find that the atomic number, which is n, is equal to 4 atom. If we get 4 atom, which means we have the FCC structure. Okay. Let's move on to the other question. He asked us to compute the linear density for this direction, 110. Okay, this is X, Y, and Z. Okay, based on this direction, we can know that it is along the XY direction. There is no height in this direction, okay? It is the XY plane, okay? Okay. And also, it is FCC structure based on what we get in the previous part. Okay, we know that the linear density is the number of the atoms along the line direction of the vector divided by the length of this directional vector. Okay, let's draw the direction, which is basically 1 along the x-axis and 1 with y-axis. Okay, we move 1 and 1 just from the beginning point to the final point. You will gonna have the direction. Okay. Okay, how many atoms that we have in this direction? We have like here 1R, 1R, and here 2R. So basically we have 4R, which means in each atom we have 2R. So we have 2 atoms in this direction. Okay. How can we find the length of this direction? Basically by using the Pythagoras. Okay. It is a square plus, this is the side a, and this is a square is equal to, we get this 4r square, which is basically 2a square, 16r square. A is equal to 2 square root of 2r. We did it many times, so you have to memorize it very well. Okay. Then after we get the length, what we have to do, just basically to plug in this number in on the equation. So the number of the atoms, we get it's equal to 2. And the unit length of the vector with in terms of this, we will gonna find that it is equal to 4r. Okay, it is 4r. Or there is some other solution that you find the unit length based on the a variable. How? You know that this is a and this is a, so this is basically is square root of 2a, and then you have to convert it another time to be in r terms. Okay, so this is easier to take the radius directly and when it's will gonna work with you if you have like a structure like in the FCC structure, it will gonna work very well, and if you have the PC structure, it will not gonna work. So you are not know the number of the atoms very well in this or the length very well on this direction. Okay, just substitute. We have 2, 4 and r. We have r, it's given already in the main question, which is 0.128. Okay, we have to convert it in meter. 128 multiplied by 10 to the power minus 9, and the value it will gonna be 3.9 feet 10 to the power 9 meter per meter. Okay, you can convert it also to nanometer, or you can don't convert it on the main base, so you can get the answer directly in nanometer. It is based on the choices that they give you, or the ask you if he want to find it in nanometer or meter, so it is depends on. Okay, in this question he need us to find the planar density, which is for 110 plane, the metal crystal structure. Okay, what we can do, we can just draw the plane. Okay, he gives us it is 110. 110, which is mean this is for x, y, z. Okay, take the reciprocal, it will gonna be 1, 1 and infinity. So it is parallel to the z-axis. It is not across it, never. Okay, so we have here, let's change the color. We have here an x direction, and also it is 1 in the y direction. So this is the plane, and also it is parallel to the z-axis. So this is our plane. Okay. What is the equation of the planar density? It is the number of the atoms per unit area, which is we can have this simulation for the plane. For sure, it is not accurate drawing, but it is like an imaginary atoms. Okay, we have here half atom, quarter, quarter, quarter. So we can have here 4 multiplying by quarter plus 2 multiplying, we have here half. So it is 1 plus 1, which is 2 atoms per unit cell. Okay. We know the number of the atoms. So the area of the plane, we need to know this side and this side. Okay. This side already we know it's A. And this side we can know it by using the Pythagoras theorem. Okay. it is basically, we can find it by using this relationship a square plus a square. So it is same as this side. So a square plus a square, which is equal to 2a square, which is equal to, let's name it L. Okay, we will gonna have 2a square is equal to L. Take the square root, L square, L square, take the square root, L will gonna be 2 square root of 2a. Okay, just plug in this. This is will gonna be the length of the our shape, multiplying by the width, which is a. So it will gonna be a multiplying by square root of 2a. Do we know a? Yes, we know it. Just plug in the numbers and you will gonna find that it is equal to 1.0789 multiplying by 10 to the power 19 meter per meter square. Okay, let's go to the other part, which is gives us another plane, and he needs us to find the planar density. Okay, in the same structure, which is FCC. Okay, let's just draw it. We have 1, 1, 1, which is cross the one in the x-axis and also cross the one in the y-axis and one on the z-axis. Just match it together. You will gonna have the triangle shape. Okay, and the triangle shape, if you imagine it very well, you will gonna know that it is 60, 60, 60 angle. Why? Because it is like they have the same edge length. Okay, طيب. Let's gonna draw it in another way to simplify it to our imagine, to know the value of the number of the atoms on the plane. So by redrawing it, we will gonna find that it is, we have atom in the corners, and also we have half atoms in the faces, which is here we represent the face, and here we will gonna match the faces on this. Okay, طيب. You may ask, how can we know that this atom in this corner is 1/6? Okay, we say before that this angle is 60. Okay, if this angle is 60, which what is represented by 360? Let's do it as a ratio. 360. Okay, we have 1, we have x. It will gonna be 1/6 on the full atom. Okay, so what we will gonna have? We will gonna have 3 1/6 plus 3 1/2, which is these ones. We have half atoms in the faces. Okay, we will gonna have half plus 3/2, which is 4/2, which is 2 atoms in the across the plane. Okay, we have here 3 atoms. The area of the plane, we can find it by finding the area of this triangle. We know that this is a square root of 2, as we find it in the previous question. Just we have to find this this height. Okay, طيب. How can we find this height? Same thing, we can find it by Pythagoras theorem. Okay. Okay. We can say that we can find this this length by using Pythagoras theorem. But how? Basically with this side. We know that this is equal to a, this is equal to a, and if you like if you can see that it is same as this triangle. Okay, so this is also will gonna be a square root of 2. Okay, طيب how can we, if we find this is a square root of 2 and this is a square root of 2, can we find the height? Yes, we can find the height by using the Pythagoras theorem, which is we will gonna this have this small triangle. We will gonna find this height by using the Pythagoras theorem, and we will gonna say that the hypothesis which is equal to square root of 2a, all of them square, is equal to, we said that we were gonna take just this part, which is half of this, okay, square root of 2a over 2, all of it square, plus our height, which is we have to find it. Let's like name it like h square, okay. So h is equal to, or let's h squared plus 2a over 4 square is equal to 2a square. Okay, let's have h on one side. We will gonna have 2a square minus 2a square over 4, which is we will gonna have it as h will gonna be 3 over 2a. Take the square root of both sides. You will gonna find it that it is h is equal to square root of 3 over 2a. Okay, this is the height. Okay, the area of this triangle, it will gonna be half multiplying by the base, which is square root of 2a, multiplying by the height, which is 3 over 2a. Okay, plug in this equation, which is will gonna be half multiplying by square root 3 over 2 multiplying by a multiplying by the base, which is square root of 2a. Okay. By plugging the number of the a, which is we have it in the previous questions, okay, or we don't have the a in the previous, we have r, okay, so we can replace the a's by we can replace the a's with the r. How we can do? Just let's arrange this equation. We can simplify this with this, then we will gonna have the BD is equal to 2 over square root of 3 over 2 multiplying by a square, which is, we know that the a in the FCC is equal to square root of 2 to r. So just substitute BD is equal to, up, move this to the up, you will gonna find this, it's equal to 4 over square root of 3 multiplying by a, which is 2r square. If you want to find the planar density with the nanometer, you can substitute the r with the nanometers, which is given 0.128, and then you will gonna find the planar density directly. If you want to find it with the per meter square unit, you will gonna convert this one to the meters unit. Okay, let's move on to the fourth question. He said that derive a linear density expression for BCC 110 and 111 direction in terms of atomic radius r. Okay, we have now a BCC structure, which is we have 8 atoms in the corners and 1 atom in the center of the crystal structure. So what we need to do, as we know that the linear density equation is the number of atoms across the vector direction divided by the length of the direction vector. Okay, if we need to find the number of the atoms in this vector direction, just let's us take this directional units. It will gonna represent that we have x, y, and it is doesn't across the y direction. We don't have height, so it is will gonna be this vector. Okay, this vector it will gonna be represented 1 1 0. If we draw this triangle and this, we will gonna find this. Okay, we have here half r and we have here half r, which means half r plus half r, which means one full r, which means we have one atom. Okay, now we find the number of the atoms on this directional vector. We can find the relationship between the r and the a by using the Pythagoras theorem. Okay, or we can find the length by using Pythagoras theorem. A squared plus a squared, we will gonna use the length which is we needed by x. X is equal to square root of 2a squared, which is this one. Okay, طيب. What we will gonna do is just substitute on this equation, which is we have LD is equal 1 atom we have over a square root of 2. Okay, he told us that he needs us to find it with expression with r. Okay, we have to find the expression, the relationship between the r and a. How we can do it? We just can do it by using this diagonal between this atom to this atom, crossing to the atom in the center. Okay, so by this we can have the relationship between the a and the r. Okay, so basically what we need to find this triangle. Okay, we know that this is a, and we know that we just find it, it's a square root of 2, and we need to find this one. How we can find this one? Just basically with the Pythagoras theorem. It is a square plus a square root of 2 square is equal to how many atoms we have here? We have here half, and here let's here half, and here half, and here one atom. يعني 2r هنا 2r, and here r, and here r, which means that we have 4r, all of it cube. Okay, let's rearrange it. We will gonna have a squared plus 2a squared is equal to 16r squared, which is 3a squared is equal to 16r squared. A is equal to taking the square root of 16r squared over 3, which is we will gonna have a is equal to 4r over square root of 3. Okay, just plug in it here. We will gonna have one atom over a, which is 4r square root of 3 multiplying by the square root of 2, which is we can move on this above. We will gonna have square root of 3 4 square root of 2r. Okay, this is what represent the linear density of this directional vector. Okay, let's find it for the other vector, which is 1 1 1. It is the same thing. We need to find how many atoms we have it across this line. Okay, how many r's we have? We have here full atom, which means we have 2r, and here 1r, which is in total 4r divided by 2r, which means we have 2 atoms. on this line. Okay, so we know the atoms too. طيب, what we need to find the length of the directional vector, which is this one. Okay, طيب, how can we find this length? Basically by Pythagoras theorem, which is this is triangle. We will gonna find it. Just let me show it on our plane. This is our vector. This is one side of the triangle, and this is the other side. This is we know it as a. This is we know it as square root of 2a, and this one that we know, we have to know its length. Okay, by using the Pythagoras theorem, just we will gonna find the length is equal to a square root of 3. Plug in it, we see that it is equal to a square root of 3. Okay, we know the relationship between a and r from the previous question, which is a is equal to 4r over the square root of 3. So it is equal to over 4r over square root of 3 multiplying by square root of 3. This will cancel for this, and we will gonna have that it is equal the linear density of this direction. It's equal to 1 over 2r. Okay. Then he asked us to compute to compute and compare the linear density value for the same two direction to for the tungsten. Okay, he must give you the radius value of the tungsten, and then you will gonna plug in it in the equation that we get. You will gonna plug in it in this equation and also in this equation, and you will gonna find these numbers. Okay, this is for 110 and this is for 111. The crystal structure that we have, as it's mentioned in the question, we have it as a BBC, which is the more dense. It's along the diagonal vector, right? Which means in the 111, which is represent the diagonal, we must have the more dense. We must have a higher density on this vector. And if you get like this is much lower than that, you know that you make some mistakes in your calculation. Okay, this is the explanation of why it's in the 111, why we have bigger density than 110. Okay, let's move on to the fifth question, which is he asked us to derive the density expression for the FCC 100 and 11 planes in terms of the atomic radius. So if you can see that we did previously in this homework, we found the planar density of 11 already, صح؟ يعني in where I can show you. This is basically we found the 111 a planar density for the FCC, and this the whole thing it is will gonna be the same as that question. Okay, for just the 111. Okay, he asked us to find also for 100. Okay, where's the 110 100 plane will gonna be? It will gonna be the front one. It is, let's find the reciprocal 1 infinity infinity. Okay, it is parallel to the y-axis and also parallel to the z-axis, so it will be represented as this plane. Okay, the planar density is basically the number of the atoms along the plane and also over the area of the plane. So what we will gonna do, basically we know the area of the plane, which is a square. It is a square planar. Okay, and the number of the atoms, how we can do, we know that we have here quarter, 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 and 4 atoms, so 4 multiplying by 1 over 4, and we have 1 in the center, which is plus 1. So basically at the end we will gonna have 2 atoms. Okay, He said that he wanted in terms of radius. So we can't just say that area is equal to a square. We have to convert it into our terms. How we can convert it? We can take it from Pythagoras theorem. Just take this plane and put it as this. You will gonna find this side is equal to a and the side is equal to c, and this we have for r. Okay, just make the Pythagoras theorem. You will gonna find that a is equal to square root of 2r. We did it many times in this homework, so just plugging it into here, you will gonna find that the planar density of this is equal to 2 over 2 square root of 2r, all of it square. Okay, we will gonna find that for 2r, this will cancel 1 over 4r for this one. Okay, as I mentioned, the 111 plane, we did it previously, so we don't have to redo it. Okay, he needs us from the part B compute and compare the planar density values for the two planes of nickel. He must also give us the radius of the nickel. It is 0.24 nanometers, which is equivalent to 1.24 multiplying by 10 to the power minus 10 meter. So just to plug in the numbers. Just plug in the numbers into these equations. You will gonna find that the density along the plane 111 is greater than the plane 100. Why? Because we have a much more atom in the plane 111. Okay,